Pythagorean Theorem. And its converse. All right, hopefully this is review. The Pythagorean Theorem is a formula that is used to find the missing side of a right triangle. You can only use the Pythagorean Theorem on a right triangle. Alright, you got vertices A, B, and C, and we're going to call the sides opposite of each vertex lowercase a, lowercase b, and lowercase c. The side across from the right angle is called the hypotenuse. And it is, anybody remember anything about the hypotenuse? Yes. It's always the longest side. So we're going to say always longest. It's always the longest side in the triangle. The Pythagorean Theorem says that in a right triangle, side A squared plus side B squared is always equal to side C squared. Everybody all right with that? Very good, very good. Anybody need to see an example? Okay, sure. We'll call side A 6 and side B 15, and let's find side C. So if you know two sides of the triangle, you substitute those values into the formula or to the theorem. So you would have 6 squared plus 15 squared equals C squared. In your calculator, you can just put 6x squared plus 15x squared, and it's a little bit of a shortcut. And 261 is equal to C squared. And now if you find the square root of each side of this equal sign, it will give you the value of C. And you should just be able to push the square root button in your calculator and get 16 point, we're going to round everything to the nearest tenth, so we've got 16.2 is equal to C. And just a quick self-check is that the hypotenuse is always the longest side, and the value we just got for the hypotenuse is longer than the 15 and the 6, so you probably did everything right. Clear? Very good, very good. Look down at the bottom of page 548. Bottom of page 548. A Pythagorean triple is a set of 3 non-zero whole numbers. A, B, and C. Such that A squared plus B squared equals C squared. There was a quiz question on this, and a fair amount of people got it wrong. And I think you just didn't put the effort in to memorize the definition. Right here. Set of 3 non-zero whole numbers. You can have 3 sides that form a right triangle. But if all the numbers aren't whole numbers, then the sides don't form a Pythagorean triple. Okay, we just did this problem. We used a squared plus b squared, made it equal to c squared. But this answer, this third side, is it a non-zero whole number? It's not a whole number. So these 3 sides, the 6, the 15, and the 16.2, do not form a Pythagorean triple. They do form a right triangle. Okay? But the set of numbers is not a Pythagorean triple. They all have to be whole numbers. They all have to be non-zero whole numbers. 3 non-zero whole numbers such that a squared plus b squared equals c squared. Meaning the 2 smaller ones, the 2 smaller of the 3 numbers, squared and added together equal the third number squared. And they give you a list of common Pythagorean triples on the bottom of page 548. Okay? In your assignment today and on your quiz and on your practice on Wednesday, you're going to be given some directions like use Pythagorean triples to solve the triangle. And what they're asking you to do is they're kind of saying memorize this list of triples. But you don't need to do that because you can always just use the Pythagorean Theorem. Okay? But some of the really common triangles that we've seen a bunch of this year, hopefully you're going to get to the point where you don't keep doing the Pythagorean Theorem when one of the legs is 3 and then another leg is 4. Okay? What's the third leg or what's the hypotenuse going to be every time in a right triangle? This is going to be 5. Alright? It's the first one on the list. Okay? A 3, 4, 5 is a right triangle. Okay? Always. Okay. Look at the top of page 549. Use the Pythagorean triple. You don't need to use the Pythagorean triple, but if you see some triangles, another real common one, another real common right triangle, okay, is if this is 10 and this is 8. Alright, a 6, 8, 10 is always a right triangle. Alright, this is 36, 64. 36 plus 64 equals 100. So that's another very common Pythagorean triple. Maybe it can save you some time. Alright, and then finally in this section, look at page 550. Converse of the Pythagorean Theorem. We've covered this where they said that if a squared, let's see, here's the rule, and here's the type of triangle. If your 3 sides, a squared and b squared, the sum of a squared plus b squared equals c squared, the type of triangle, that was a right triangle, wasn't it? So you could be given 3 legs of a triangle and ask if the triangle is a right triangle. Well, then you take the 2 shorter ones, you square them, you add them together, and if they equal the longest side squared, it's a right triangle. Then, remember when a squared plus b squared was greater than c squared. Alright, that is an acute triangle. When the 2 shorter sides, the sum of the squares of the shorter sides, is greater than the third side, that is an acute triangle. And when your a squared plus your b squared is less than your c squared, when the sum of the shorter sides squared is less than the third side squared, then that was a obtuse triangle. Alright, so those are the types of problems you're going to see today. You're going to be asked to find the third side of a triangle. And you're going to be asked to determine if the triangle is right, acute, or obtuse. Anybody got any questions on any of that? Very good, very good. Your assignment for today is going to start on, let's do page 552. through 26. Page 552, 9 through 26, and you have a quiz on Thursday.